In this video, I'm going to do questions 4, 5, 6 from exercise 9C of Pure 2 A-level textbook. So this chapter is all about differentiation and exercise 9C is about chain rule. So let's get started. Question 4 says that a curve C has equation y is equal to 5 minus 2x cubed. Find the tangent to the curve at the point P with x coordinates 1. Right, so we need to find the equation of the tangent, and the first thing we need to do is that we simply need to differentiate the equation of the curve so that we can find the gradient at point P in this case. So we can start by writing down the equation of the curve, which is 5 minus 2x cubed. So the first thing is differentiating the equation of the curve, and in this type, so the power comes down times the derivative of inside. In this case, the derivative of inside is just minus 2. Now we write down inside, but with this power minus 1, which is 2. So we can simplify this, which is minus 6 times 5 minus 2x squared. And now we want to know the gradient at point P, which has the x coordinate 1. So we just need to substitute 1 into this, because that's our derivative. So when x is equal to 1, we have, so dy by dx is equal to minus 6 times 5 minus 2 times 1 squared. So now let's work out the value of the gradient. So minus 6 times 5 minus 2 is 3, and 3 squared is 9, which is minus 54. So this is the gradient. So this is the gradient of the curve at P, or at point P. Now the next step is working out the coordinates of point P. Remember that we only have the x coordinate, which is 1, but we don't know the y coordinate. So if you want to find the y coordinate of point P, we just need to substitute 1 into the equation of the curve. So we can write that here. So y is equal to, so the equation is 5 minus 2 times 1 cubed. So 5 minus 2 times 1 cubed. And this gives us, so 5 minus 2 cubed, and that's 3 cubed, which is 27. So this is the y coordinate of P, so we can write down P as 27. So this is the coordinate of the point P. Now we have everything, and we just need to use the equation of basically of the straight line, and that helps us to find the equation of the tangent. So remember that this is the equation from chapter 5 of Pure 1. Y minus y1 is equal to m times x minus x1. So this is the equation of a straight line, or in this case the equation of the tangent, because tangent is also a straight line. So y1 is the y coordinate of the point, in this case is 27, and x1 is the x coordinate of the point, which is 1, and m is the gradient. So now let's substitute the values into this general form. So y minus 27 is equal to, so we got minus 54 as our gradient, and x minus 1. So yeah, this is the equation of the tangent, and the question hasn't asked us to simplify this, so feel free to continue and simplify this equation, because you can just expand this from here and then add 27 to both sides, so you will have the final form as y is equal to something. Right, now let's do question 5. Given that y is equal to 1 plus the natural log of 4x to the power of 3 over 2, find the value of dy dx at x is equal to 1/4 of e cubed. Right, so again, this is simply finding the gradient when x is equal to this value. So we need to differentiate y. dy by dx is equal to. So here, again, this is pretty similar to this question where we differentiated y, but in this case, the function which is inside is also a bit more involved. So again, we start by writing down the power, so 3 over 2 times. Now the derivative of the inside. So remember that the derivative of natural log of 4x. So whenever you have natural log of something, its derivative is equal to. So let's say you have the natural log of f of x, and you want to differentiate this. So as your derivative, you will have let's say this is your y, and then your dy by dx is equal to, so f dash x divided by f of x, which simply means whenever you have the natural log of something, its derivative is equal to the derivative of that function over the function. So in this case, the derivative of 4x is just 4 over 4x, because 4x, that's the function. And of course, we can simplify this, which simplifies to 1 over x times, so the bracket, and now the power of the bracket minus 1, and we get a half. So now let's simplify this. We get dy dx is equal to, so this 4 cancels out with this 4, and we have 3 over 2, or 3 over 2x, let's write that in this way, times 1 plus ln 4x to the half. Now we want to know the derivative at this basically x value, so we can now write here in this way. So when x is 1 over 4e to the 3, dy by dx is equal to, so now let's substitute that into this. So we have 3 over 2 times x, which is our x is 1 over 4. So let's write that in this way, because so we will have 1 over 4. So since this is because we should be careful, I was about to make a mistake, so let's do that again. We should be careful because our x value in the denominator is this, x cubed over 4. So this is important. So 2 times x cubed over 4. And in numerator we have so bracket 1 plus the natural log of 4 times x. So 4 times 1 over 4 e cubed is just e cubed. Very simple. And of course the power, which is 1 over 2. Right, now let's simplify this. So for this step, these 2 cancels out with this one, and we will get 2 here. And interestingly, inside the bracket, the natural log of e cubed is just 3, because by using the log laws, and since e is the basically natural log, so the natural log is the inverse function of e, then basically these 2 cancel each other out, and we will only get 3. Because remember that when we have the natural log of something to some power, then that power can come outside. So just write that for you. The natural log of this can be written as 3 natural log of e, and these 2 cancel each other out, and you will get a 1, because this is the inverse function of this, so you will only get 3 at the end. So that's a nice one. So inside, so here you will get 3, and 3 plus 1 is 4, so you will have 3 times 4 to the power, or power over half, divided by e cubed over 2. So 4 to the power of a half is the same as the square root of 4, which is 2. So 2 times 3 is 6. 6 divided by e cubed over 2, and that's simply 12 over e cubed, and you can rewrite this as 12 e to the minus 3. And that's it. So this is your final answer. This is the gradient at this point. So this one wasn't, a challenging question, but the differentiations, were a bit more involved. Question 6. Find divide dx for the following curves, giving your answers in terms of y. A. X is equal to y cubed plus y. So hopefully you can realize that this question is all about implicit differentiation. So we don't have our functions as this classic form of y is equal to something, or y in terms of x. So we should be careful about this question, and especially later on when we learn product rule. They really like to combine product rule with implicit differentiation, because many students are likely to make mistakes on those questions. Right. So now we want to differentiate this implicitly, and x differentiates to 1 because we are differentiating each term with respect to x. So basically the derivative of x with respect to x is 1 as usual, but the derivative of y squared with respect to x is equal to 2y dy dx, and the derivative of y with respect to x is dy dx. So now we have technically, we are now done with the differentiation, but we haven't quite, completed the question. That's simply because it says give your answers in terms of y. And as you can see, our answers aren't in that form. So let's keep 1 on the left-hand side for now. And hopefully you can realize that we have two terms which have divide dx on the right-hand side. So we can factorize that. So dy dx. And then we will have 2x plus 1. And the next step is pretty obvious. So we just divide both sides by 2x plus... here should have been y, not x. To y plus 1. Now the next step is dividing both sides by 2y plus 1, so that we will have our answers in terms of y. So dy by dx is equal to 1 over 2y plus 1, and that's it. B, we have x is equal to e to the y plus 4y. Again, x differentiates to 1 because we are differentiating with respect to x. E to the y differentiates to e to the y dy by dx. Be careful. 4y differentiates to 4 dy by dx. And the same trick. So we need to factorize the right-hand side in order to get our final answer in terms of y. So we have a factor of dy by dx. We will have e to the y plus 4. Now divide both sides by this bracket. Dy by dx is equal to 1 over e to the y plus 4. And that's it. This is the answer of this question in terms of y. C, x is equal to sine 2y. X differentiates to 1 with respect to x. Sine 2y. So sine 2y with respect to x, it differentiates to 2 cos 2y dy by dx. Because remember that when you're differentiating trigonometric functions, you first differentiate the inside, and that comes out, and then you differentiate that specific trigonometric function. In this case, you have sine, so sine differentiates to cos. And of course, since this is implicit differentiation, we should have dy by dx at the end. Now, this one is even simpler because we just need to divide both sides by 2 cos 2y, so that we get our final answer in terms of y. Dy by dx is equal to 1 over 2 cos 2y. So, and that's it for this question. But you still can simplify this one more step, because remember that 1 over cosine is sec or secant. So in this case, 1 over 2 cos 2y can be written as a half sec 2y. So that's another way of writing your final answer. But it's completely fine if you leave your answer in this form. And the last one for today, so 4x is equal to the natural log of y plus y cubed. Again, we need to differentiate each term with respect to x. So 4x differentiates to 4, ln y differentiates to 1 over y, and y cubed, 1 over y divided by dx. And y cubed differentiates to 3y squared divided by dx. So this is similar to the first two examples. Now we need to factorize the right hand side. So dy by dx. So bracket 1 over y plus 3y squared. So yeah, of course we can factor a y term out, but remember that we want to give our answers in terms of y. So we shouldn't basically be doing that for this question. Now, as the last step, we can divide both sides by the bracket. So we have dy by dx is equal to 4 over 1 over y plus 3y squared. So that's the final answer in terms of y, but we can simplify this because it's not in a very nice form. So let's simplify this. Okay, we can simplify the denominator. So we can take the common denominator of y. So we will have 1 plus 3y cubed, and this simplifies to 4y divided by 1 plus 3y cubed. And that's it for this video. I hope this helps you, and make sure to subscribe for more videos. Good luck.